My name is Gyroscopic and my roll number is 162. I am from SYA. My topic for IEC 1 of dynamics of machine is effect of gyroscopic couple on ship during steering motion. Introduction to gyroscope. What is gyroscope? So gyroscope is a rotating body mounted such that its axis can change direction. When axis of rotation is forced to change, the gyroscopic couple acts. What it means? When there are three axes, x-axis, y-axis and z-axis, we can see that when the rotating body or spinning body is at x-axis and it is rotated at the axis of precision or y-axis, that is axis of precision. At that time, the third gyroscopic couple, that is acting at the z-axis, that is third axis. The couple produces this couple acting along the third axis produces angular acceleration, and this angular acceleration is called as gyroscopic acceleration. And in this example of ship, the propeller is rotating. Because of the propeller, the gyroscopic effect is taking place. What are the terms used in naval ships and motion of ship? First one is bow. We can see here bow is the front end of the ship. Second one is stern. Stern is the rear end of ship. Port side is the left side of the ship. This is port side, and this is starboard side, which is right side of the ship. When we are moving from the stern end, now what are three axes along this? First one is longitudinal axis. This is longitudinal axis, and this is longitudinal axis, and this is transverse axis. It is along the width of the ship, and longitudinal axis is along the length of the ship. Vertical axis is through the ship along the center of the ship, which will be acting in the vertical direction. And what are the motions that ship undergo? First one is steering motion, which we are going to see, and pitching motion and rolling motion. In steering motion, it takes place due to turning right or left. In pitching motion, up and down motion of the ship takes place, and rolling motion, it is sidewise tilting of ship. So in this presentation, we are going to focus on steering motion only. Gyroscopic action during steering motion. So we can see that propeller rotates with the angular velocity omega about the longitudinal axis. The propeller, when we see from the stern end, the propeller is rotating in the clockwise direction, and during the steering of the ship, that ship turns towards any direction like left or right. The axis of spin changes, so that we are seeing from the stern end the axis of rotation is clockwise, and when we change the axis of rotation, that was x-axis, and it is rotated about the y-axis, that is axis of precision. That it causes precisional motion about the vertical axis. Due to this, gyroscopic couple acts in the transverse axis. Transverse axis is z-axis. Axis summary. Axis of spin is longitudinal axis. Axis of precision is vertical axis, and axis of gyroscopic couple is transverse axis, that is z-axis. Gyroscopic couple equation. Gyroscopic couple is denoted by C, and its equation is C equals to I omega into omega p, where I is mass moment of inertia, and omega is angular velocity of propeller, and omega p is angular velocity of precision. We can write omega p also as V by R, where V is velocity and R is radius. The effect during left and right steering, we have to assume that the propeller is rotating in the clockwise direction, when we are viewing from the stern end, the ship is steering to the left side, and the reactive gyroscopic couple is acting anti-clockwise, and active gyroscopic couple is acting clockwise, and reactive is acting anti-clockwise. So the bow will rise and stern, bow side will rise and stern side will lower. Similarly, when the ship is steering to the right, reactive gyroscopic couple, active gyroscopic couple will act anti-clockwise, and reactive gyroscopic couple will act clockwise. This affects in lower the bow and rises the stern. Physical thumb rule which can be applied to this gyroscopic couple is when we are looking from the stern end, we can see that our curved fingers are showing the clockwise rotation of propeller, and we can see that thumb is pointing away from us. So it is showing the direction of motion of ship, that is away from us. As it takes the right turn or left turn, and as it takes left turn, the direction of fingers points the direction of gyroscopic couple. So when it is taking the left turn, the motion of fingers is in clockwise direction. So reactive gyroscopic couple will act in anti-clockwise direction, and when it is taking the right turn, that means the thumb will point towards the right, and the curved fingers will show anti-clockwise direction, that is in clockwise direction. Reaction of gyroscopic couple will act, and as a conclusion, the gyroscopic couple significantly affects the ship's stability as it acts towards the third axis, and designers must consider this while designing the ship. Thank you.